So far, we have learned vertex form for quadratic functions, and we've been able to identify our vertex, axis of symmetry, and a few other things from our equation, and we've also graphed our quadratics that are in vertex form. Now we're going to go the other way. We have a situation where, in this case, we have the jump of a dolphin, and we see the graph that goes along with our data. We want to write a quadratic function that models the path of this dolphin's jump. So let's look at what we have here. A vertex form, the most helpful piece of information to know is our vertex. So where is our turning point for our parabola? Well, it's somewhere around here, and it might be kind of hard to tell. Is it here, or here, or here? Well, it looks like it might be right here at this point 3, 7. And to double check, remember that our parabolas are symmetric. So if this point 3, 7 is really my vertex, I should have the same thing on both sides. So I see right over here at 0, 6, I have a nice point. That's 3 over from what I think might be my vertex. If that really is my vertex, if I go 3 the other direction, I should also have that same y value. Okay, and I do. So that means this point right here, 3, 7, is my vertex. So I'm going to go to my paper, and I'll switch back and forth between a little bit. So I'm calling this example 2a, writing an equation in vertex form. We know our vertex is the point 3, 7. Well, let's start off with what vertex form is. Vertex form is y equals a times x minus h squared plus k. And remember that really this is all transformations. Okay, this a value is our vertical stretch or shrink, h is our translation left and right, k is our translation up and down. So if my vertex is at 3, translated 3 to the right, you can plug this in. And the 7, translated 7 up, that goes in for k. And after I do that, I get y equals a times x minus 3 squared plus 7. And once I get my function, I should still have the x and the y, but how am I going to figure out a? Well, let's look back at our diagram. Okay, I know my vertex. Well, if I find another ordered pair on this graph, that'll give me another xy pair. And if I find my x and my y, that'll give me, I can use that to solve for a. So just looking at our graph here, well, we said this point works out pretty easily. That 0, 6, it looks like. I guess it's kind of hard to tell for sure if that really is a point or not, because right over here, 6, 6, it looks like that y value, or it looks like the graph is a little bit above. But if I follow this through, right here is an easier point to find, 9, 4. So let's use that, just because I'm pretty confident that that is a point on our graph, 9, 4. So back to my paper. We know another point was 9, 4. Plug it in. Plug this in for x and y. 4 equals a times x is 9 minus 3 squared plus 7. I only have one variable now. I can solve for it, put that all together to get my function in vertex form. All right, 9 minus 3 is 6. A times 6 squared plus 7 equals 4. 6 squared is 36. Subtract 7 from both sides. And then divide by 36. So a is negative 3 over 36, which simplifies to negative 1/12. Now we really have all the information we need to get our equation in vertex form. I know a now, we know h, we know k. And again, our function should have an x and a y in it. So put this all together. Y equals negative 1/12 x minus 3 squared plus 7. That is my function in vertex form.